In 2018, as I'm sure everyone at this conference knows, the total fertility rate was below replacement level in every European country. And I'm sure everyone also knows that if you have zero migration, then sustained below replacement fertility will lead to eventually to a decreasing population size. However, in 2018, in about 2/3 of European countries, net migration was positive. So in this presentation, what I'm going to explore is the answers to two very simple questions. Firstly, would constant fertility, mortality, and migration at the levels that have been observed recently in a selection of European countries lead to population decrease or to population increase? And secondly, if net migration and mortality remain at the levels which prevail for a particular year, which level of total fertility would be consistent with long-run zero population growth? The theory behind the method that I'm going to follow is best articulated in a paper by Espenschade, Bouvier, and Arthur. They tell us that as long as fertility is below replacement, a constant number and age distribution of immigrants with constant mortality will lead towards a stationary population. Actually, this was found by my former boss, John Pollard, somewhat earlier. The stationary population can be seen as the sum of components which are related to migration indexed generations. The first generation is calculated by at each age you take net migration, you multiply that by remaining life expectancy, and you sum the results across age and sex groups. The second generation component is what you get if you apply fertility rates to the female surviving net migrants, so to speak, and multiply the male and female births by male and female life expectancy at birth. And then down at the foot of the screen is the expression for the total size of the stationary population, considering all the various migrant index generations. And in a recent paper, which appeared in the European Journal of Population, I showed that you can calculate a total fertility rate, which in combination with the migration and mortality patterns for a particular population and year produces a stationary population, leads to a stationary population which is equal to the current population, POP in the formula. And this formula is expressed as the product of two terms. The first on the left is total fertility rate over net reproduction rate. That is the familiar slightly less than 2.1 replacement level for fertility in low mortality context, that is. And therefore the second term can be seen as a term which adjusts that familiar replacement level for migration being non-zero. And that second term is derived from the size of the first generation component, the second generation component, and the net reproduction rate. So what I'm going to do is to just present very simple graphs showing the trends in total fertility rate for a range of European countries. And then on the same graph is the trend for the values of this so-called migration adjusted replacement level. So here we see the example of Sweden. The total fertility rate graph is shown in blue. The migration adjusted replacement level is shown in red. So if for a particular graph, the blue line is above the red line, then what that shows is that a projection with constant fertility, mortality, and migration as per the levels for that particular population and year will lead towards a larger population than the actual population for that year. And conversely, if the blue line is below the red line, then a constant fertility, mortality, migration projection will lead to a smaller than current population. And the value for the red line shows the value for total fertility rate, which would equate stationary population size with current population size. In other words, that value gives us a zero population growth scenario for fertility with constant mortality and migration. So in this first graph, it's clear that in every year within the period that's observed, the total fertility rate for Sweden was above the migration adjusted replacement level. And this tells us that for Sweden, for any of these years, constant fertility, mortality, migration is consistent with long-run population growth. Considering the values shown by the red line, we can see that for Sweden, total fertility could fall into the so-called very low fertility range, below 1.5, even it's for some years below 1.2. And if it were to sustain its levels of migration and mortality, the population would still grow. The next graph I'm showing is for Norway, and this is an interesting graph. In the early part of the time period considered, the patterns for Norway are broadly similar to those that I described for Sweden. Fertility was substantially above migration adjusted replacement level. However, over the course of this decade, there were two substantial changes that are shown by the graphs. Firstly, the total fertility rate for Norway fell considerably to below 1.6. The graph shows us that had the level of migration adjusted replacement remained around the levels it was in the early part of the time period, then even with this lower total fertility rate, Norway would still have a population growth producing combination of fertility, mortality, and migration. However, we also see that concurrent with the reduction in value of total fertility, the value of the migration adjusted replacement level rose considerably during the course of this decade. And underpinning that was that net migration to Norway fell considerably. My power wasn't turned on, I got a message. So for the 2018 values, if there was constant fertility, mortality, migration, the population of Norway would actually fall very slightly. The graph on the right for Switzerland is another very interesting graph. Compared to Norway and Sweden, Switzerland has a significantly lower TFR, just about 1.5 births per woman. And over the course of the decade, there was little change to that level. In the early part of the decade, however, even with this quite low level of fertility, Switzerland had a population growth coherent combination. However, over the course of the decade, you see the value of the red line rose substantially. Underpinning this was that the level of net migration to Switzerland fell. And so for the last 2 years, Switzerland had a below migration adjusted replacement level of fertility, a population decrease coherent combination, even though its fertility level has barely changed. For Netherlands and Denmark, I won't say too much due to time. You see that for both countries, the TFR went down a bit. The relationship between the TFR and replacement level fluctuated over the course of the decade, and this was more due to the fluctuation in the migration adjusted replacement level. My favorite graph is the one for Germany. And this graph shows in the early part of the decade considered, Germany had a very low fertility level. It also at that time had quite a low level of net migration. And so fertility was far below migration adjusted replacement level. However, over the latter part of the time period, you see that the TFR is actually above the migration adjusted replacement level. This change, this crossover, is the product of two trends. Firstly, the TFR rose, and secondly, over the latter part of the period, net migration to Germany was at a significantly higher level than earlier on. The standout feature of the graph is this huge icicle or stalactite corresponding to the year 2015. That was a year in which there was very high net migration into Germany. You may recall there was a large inflow of refugees from Syria and other countries. And the migration adjusted replacement level tells us that suppose, just hypothetically, year in, year out, Germany had migration at the level it had in that particular year, then a TFR of just 0.4 would suffice for maintaining long-run zero population growth. On the right is the graph for Finland. Again, there's a crossover, but there was a little change to the migration adjusted replacement level. The reason for the change from above replacement to below replacement was that Finland had a large reduction in total fertility.
Nick, you have 20 seconds to finish.
Great, yeah. In contrast, Hungary had the largest increase in TFR over the period, but despite that increase, even in 2018, it was below replacement level. And lastly, Italy, you see, was also far below migration adjusted replacement level. And so I believe that brings me to the end of my time. So I'll skip the summary. These are the references that I've used. I've highlighted the paper in the European Journal of Population, which shows the method. And there's a spreadsheet on my ResearchGate page. I think I'm spot on 12 minutes with that.